Dimensional analysis. In my previous video, I explained what is dimension of a physical quantity. In this video, I'm going to explain application of dimensional analysis. So there are three applications. First one is to convert a physical quantity from one system of units to another. Second, check the dimensional correctness of a given physical equation. Third one, establish the relation among various physical quantities. In this video, I am going to explain the first application. First, I will explain how to convert a physical quantity from one system of units to another by the method of dimensional analysis. It is based on the fact that the product of the numerical value and the unit is a constant. That means n1 into u1 will be same as n2 u2. You consider a physical quantity which has dimension a in mass, b in length and c in time. Let m1, l1, t1 be the unit in one system and m2, l2, n2 is the unit in the other system. Then n1, numerical value in one system, n1 into m1 raised to a, l1 raised to b, t1 raised to c, where m1, l1, t1 are the units in one system. That is equal to n2, numerical value in the second system, into m2 raised to a, l2 raised to b, t2 raised to c, where a, b, c are the dimensions in mass, length, time respectively. Let us try to understand this by an example. Atmospheric pressure is expressed in terms of the height of the mercury column. Atmosphere is exerting pressure, so mercury will stand up to a height of 76 centimeter. You have to express the atmospheric pressure in Newton per meter square. It is given in terms of the height of the mercury column, 76 centimeter. First you have to express in dyne per centimeter square. So pressure is given by the formula HdG, height of the mercury column 76, density 13.6, acceleration due to gravity in CGS system 980. So this is the atmospheric pressure in CGS system. Then dimensional formula for pressure you can get from this. Pressure is force divided by area. Force mass into acceleration. Acceleration dimension is LT raised to minus 2. Area L square. 1 L will get cancelled. So dimension for pressure is M L raised to minus 1 T raised to minus 2. M1, L1, T1 are the units in the first system. So gram, centimeter, second. M2, L2, T2 are the units in the second system. Kilogram, meter, second. Now already you have seen the product of the numerical value and the unit will be a constant. So in the first system, numerical value is P1. M1, L1, T1 are the units in the first system. A, B, C are the dimensions of M, L and T. In this case, A is 1, B is minus 1, C is minus 2. Then our aim is to find the pressure in the second system, so P2. So if you rearrange this, you will get like this: P1, then M1 by M2 raised to A, next L1 by L2 raised to B, T1 by T2 raised to C. Now for P1, we can substitute this value of the atmospheric pressure in the CGS system, that is P1. Then M1, that is 1 gram. Second system M2, that is 1 kilogram. L1 in the first system unit is centimeter. L2 second system, it is meter. T1 1 second, T2 1 second. Now A is 1, B is -1, C is -2. Second system is SI system. So here gram, you convert it into kilogram. 10 raised to gram can be written as 10 raised to -3 kilogram. See, denominator kilogram, numerator kilogram. So you convert gram into kilogram. Similarly here centimeter, write it in meter, 10 raised to -2. Then in both the system here time is measured in seconds, so you need not change there. Then here -2, outside power is there -1, so minus into minus, this power will become +2. Then you multiply this, you will get this answer, 1.01 into 10 raised to 5 Newton per meter square. So we have converted the atmospheric pressure from the CGS system to SI system. So by the method of dimension, we can convert from one system of units to another system of units. Let us see one more example. Gravitational constant in SI system is given 6.6 into 10 raised to -11 Newton meter square kilogram raised to -2. So you have to get the value of the gravitational constant in CGS system. For that, you should know the dimension of the gravitational constant. That I will explain first. According to Newton's universal law of gravitation, force between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance. So it can be written like that, F is equal to G m1 m2 by r square, where G is the gravitational constant. If you rearrange, you can get an like this, G is equal to Fr square divided by m1 into m2. Then dimension of the force. Force is mass into acceleration. Mass dimension is m, capital M. Acceleration LT raised to -2. R, distance. Distance is measured in length. Length dimension is L. Mass is measured in kilogram, but its dimension is M, capital M. So M square. M square. One M will get cancelled. So in the denominator there will be an M. So it will be M raised to -1. L square and L cube, then T raised to -2. So this is the dimension of the gravitational constant. Then unit you can get from this formula. F is force. Force is measured in Newton. Distance is measured in meter, so meter square. Then mass is measured in kilogram. Again mass is there, so kilogram square. So this is the unit for gravitational constant in SI system. You have to get it, the value of the gravitational constant in CGS system. So this is the dimension of gravitational constant. Numerical value in the first system N1, numerical value in the second system N2, numerical value into unit in the first system will be equal to numerical value in the second system into unit in the second system. ABC are the dimensions in mass, length, time. We have to get the value, numerical value in the second system. So N2 is equal to N1, then M1 by M2 power A, L1 by L2 power B, or N1 T1 by T2 power C. N1 the numerical value in the first system. First system is a SI numerical value of the gravitational constant in the SI system. We have to get the value of the gravitational constant in the CGS system. For N2 we can write capital G CGS, N1 we can write capital G SI, M1 that is the unit in the first system. First unit in the first system is kilogram. Unit in the second system gram. Next L1 that is the unit in the first system, that is meter. L2 centimeter, T1 T2 both are seconds. Now gravitational constant in SI system is 6.6 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. So you convert all this gram, centimeter, second in kilogram, meter, second, because this is given in Newton meter square kilogram raised to minus 2. So here gram can be written as 10 raised to minus 3 kilogram. Centimeter can be written as 10 raised to minus 2 meter. Then when this minus 3 taken up, it will become plus 3, but outside this minus is there, so it will be 10 raised to minus 3, then minus 2, this 3, so minus 6, but when it is taken to the numerator it will become 10 raised to plus 6. Now minus 11, minus 3, minus 14 plus 6, so that is minus 8. So value of the gravitational constant in CGS system is 6.6 into 10 raised to minus 8 dyne centimeter square gram raised to minus 2. I hope you have understood this conversion of the system of units. Thank you for watching.